Dave, it's been a while. Welcome back to Computerphile.
Hello, Sean.
Thanks for joining us. Thought it'd be worth telling the story of a little mess around project that you and I did. We were discussing a logo design or a design for something, and we talked about the idea of a WAV file or an audio file, because audio is why I come to you.
Yep.
And to cut a very long story short, and so we can get into the actual code of it and everything, we talked about the idea of turning audio from a visual or a wave representation back into audio. So
Yes.
this is kind of like the world's worst sampling project, right?
Yes, or how not to sample. I think I said one of your most popular videos is how not to store passwords, and I remember texting you and saying we should call this how not to sample.
So let me just talk through the workflow, if that's not too grandiose a term for this. So I recorded me saying this. Computerphile. So that's what it looked like on the audio recorder I used.
You sent me a screen grab of it, and you were saying maybe in your logo have a wave, and then you wrote me as a bit of a joke something along the lines, oh, there'll be extra points if you can get the audio back out of this wave. Call it a challenge or something like that. You said it's a challenge. And I said, all right, challenge taken. So anyone watching this who's a great programmer, don't judge the code. This was a kind of like a 25-minute trying to quickly rush it out and get you back an audio file as quick as possible. So you sent me a high quality version of it, and it was just a bit of fun we were having during 2020.
2020 fun. So how did you go about it then? What?
So if I turn around to the side here a second, I'll get onto the screen. So basically, I'll load up the picture that you sent me. So here's the picture that you sent me. And the first thing I wanted to do was get rid of the Adobe Audition stuff around it. So I put it into Photoshop, and I kind of got the colour of the green of the grid behind, and basically removed all of that until it became this. So you can see we're pretty much left with just a black background and the wave. So in a previous video, I think it was my first ever Computerphile video, we talked about how computers sample audio. And basically you're drawing a graph of the pressure waves in the air. Then that graph obviously can be shown on the screen, and you're sending me a picture of that graph, which is obviously losing a huge amount of detail. And then I'm trying to reconstruct an audio file that we can listen to back from that. So I was looking at it and thinking, all I'm really interested in on the kind of like the vertical lines of the picture is to look at where the top and the bottom pixels are, the bright points, and basically have a min and a max for each vertical line. I keep wanting to say horizontal, but it's vertical. That was my first way of doing it. I'm sure there's loads of ways of doing it, and loads of people are going to leave comments saying, oh, you should have done it like this, and this was just a bit of fun that we did. So I've got here the code. I load in the bitmap. The file is called computerphile.png, and then I create a new bitmap. This is all in C#, by the way. I create a list of values, which is the values I'm going to get out of the bitmap. And then we go round in a loop here for the width of the bitmap. So I go from 0 to 1 before the width. And then basically I set what my max and my min. And this looks a bit weird because I've got my max set to 0 and I've got my minimum set to the height, which seems like the wrong way around, but that will make sense in a minute. So this piece of code here goes up each column of the picture. It's going from the bottom to the top on each one. It eventually spit out the minimum and the maximum value of each one. So obviously here the minimum is going to be down here and the maximum is going to be right up here. Whereas here the minimum is going to be here and the maximum is going to be here. So they're going to be different values in each column in the picture. You can see here that because a lot of it is just a solid block of colour, there's no actual wave data in that at all. There's nothing we can get from that. So all I'm doing is kind of going, well, I want the bottom there and the top there. I just want to know what those values are. And I'm not really interested in what the shape would be in the middle of that, because we don't know that. That would just be guesswork, and I fill that in later. So the way I do that is with this bit of code here, which goes up each column. And basically I set the max to 0 and the minimum to the maximum height. And then we go through and we're challenging the maximum and minimum. We're saying, well, is this new value, pick the new value, the smallest one of these two. And obviously at the moment, our minimum is set to the maximum it can be, the fullest height. So if the value I'm getting is smaller than that, then it will reset the minimum. And then as you iterate through each pixel, you're going to extract the minimum and the maximum values from here. Now, I'm telling whether a pixel is the green by its brightness. So I'm going to get the pixel at the point X and Y. And if the brightness is over 0.5, which is a scale from 0 to 1, then I'm saying it's not part of the background, it's part of the graph. For each column, I'm saying I want the minimum, maximum, minimum, maximum, minimum, maximum, all the way across the picture, and basically creating a list of numbers, which is all an audio sample is, just a list of numbers. Then I made this kind of filter here, which actually just passes a moving average over the whole thing, which just smooths it out a bit and basically stop the ringing from the sampling errors. I then, purely so I can plot the graph, I'm going to show you next, output each of the values to a text file. Here's the text file, so you get all of those values here. And then, of course, we can move over to LibreOffice and actually plot them on a graph, which is there. So that was a way of me checking it was all working and doing what I wanted it to do. Of course, if I played this, if I converted this straight to a WAV file, it would go, and it would be gone. Whereas you're saying computer file or computer file, but it's bit file. That would be far too quick, because in each one of those columns, there's probably a lot more columns because the picture you gave me was very, very squashed in. So I needed to stretch it. And of course, depending on the picture that you give me and how zoomed in or out it was, that stretch amount will change. So I had to experiment with that until I got it to something that I thought sounded like your real voice. So here I open a new file to write out this wave file. I've got a load of wave header stuff going on there. The bytes that you write for the header of a wave file to say that it's 8-bit or 16-bit or what the frequency is and sample frequency and everything. So, and then I've got this stretch value that I've set myself to 9, which will elongate or squash up the wave as I want. And then down here, for each of the value as I'm writing it out, I go round in a loop around the amount of stretches I want, and I basically add in new data. So if I'm going from this point to this point, but I want 9 places in between, so basically what you're having is you've got a minimum and maximum value, and in between you're getting a little bit of one and a lot of the other, and then as you're moving through that increment, the proportion between the weighting is going between the two. And in this case, I'm doing it in a way that's very, very crude. You might want to do it in a more kind of curved way with signs and stuff. But again, this was just a quick programming challenge from you over WhatsApp when we were having a conversation. So for each of those values, I write out value 3, which is the intermediate point, and I write that out as the file. And then finally, I set the last value to whatever the current value is, and it goes back round the loop so that it's got the previous value. Up here, I actually set the last value to 0, so I initialize the variable to 0, so it starts at 0. And then it closes the file, and it was just that simple. And I thought, I wonder whether this could work. Obviously, I didn't write it all in one go like that. I wrote out and plotted the graph, and I did it first and heard that it was squashed up and realized I needed to stretch it and add it all in. I mean, it's an iterative process. I wasn't just, write it all out in once and hit go and it all just worked magically. But much as these things seem like that sometimes, it definitely wasn't. But and I was really sort of blown away by how well it worked, to be honest. I didn't expect it to work as well as it did. I've got Audacity here. I can drag over the newly generated wave file and we can hit play.
Computer file. Computer file.
When I first heard this, it just reminded me of the sort of sampling that we got in 8-bit video games back in the day. So I remember playing a game on a Commodore 64 back in the 1980s, which had some speech synthesis on it, and it sounded like that.
Some of that was 2-bit and 4-bit. I mean, they were really, really simple. I don't know what my Acorn Electron was running back in the days. But yeah, I mean, it's effectively you're in audio terms, as someone who's more of a sort of an audio engineer in this kind of thing, if I wanted to get that sound, let's say I was doing a recording and someone said, I want that sound on my voice, I wouldn't code something. I'd grab a bit crusher or something that's going to distort it, where it's going to square things off, and it's going to effectively. So obviously, if you've got a nice smooth wave, you want to have as many levels as possible within that wave, so that you've got a nice kind of a gradation of different volumes. Effectively, that's what you're measuring, of different voltages, and the more bits you have to represent that, you know, exponentially gets bigger and bigger, and the more detail you can have. So 8 bits is so much worse than 16 bits. It's ridiculous. And 4 bits again is so much worse than 8 bits. So, and we're extracting something here that realistically, I mean, I've converted it to 8-bit, but whether I was even close to getting that kind of quality in the first place, I mean, I haven't even bothered even thought to try and work out what the source file bitrate could possibly be.
The list of numbers straight off the picture file is presumably a tiny amount of data.
It's a 35K file with the numbers,
Okay.
and that's of course written in ASCII. That's not in binary,
Yeah.
which would be, you know, a hell of a lot smaller. That was just written in a text file for me to whack in to make a spreadsheet. But I mean, I think with all of these things, with any format, if you're converting data from one place to another, there will be a way that it seems to fit sort of in its smallest sense and more naturally. But there will be you should be able to represent data in any way. I mean, I've seen videos on computerphile where you've talked about, you know, storing data in photos. You know, we know with modems and other such things, you know, that data all the time is being transmitted via audio and via light with optical signals. So whether it's the most natural format for that or not is a different thing. But bottom line is they all come down to a list of numbers at the end of the day. Everything becomes a list of numbers, you know. This whole exercise, though, then brought up a really interesting question for me, which was, so let's say I bought a stock photo on a stock photo website of a producer standing in front of a mixing desk, and on the screen behind him, he had a picture of a WAV file. And I've bought the rights to use that picture and any derivative works from it. So if I then reverse engineer the audio from that picture, can I use the audio because it came from the picture which I've had the rights to get derived works from? Which could be a real problem for, let's say, Sound on Sound magazine interviewing a famous producer, and he's got a multi-track of one of his clients up on the screen in the background. I mean, if you had a really high resolution picture of that, you know, you might be able to get out some artist single before it's been released to the, you know, to the market. There's some really interesting questions that come out of this that I think, you know, in some ways are more interesting than the quite simple code.
I suspect that the only one who's ever going to benefit from that is a lawyer's bank balance, to be honest.
Well, if there's a lawyer out there that watches this channel, then leave us a comment and tell us whether that would cause any problems or not. We're not going to pay you, though. We're not paying you for legal advice.
If anything, this might just expose the accuracy of Adobe's wave to graphics capabilities in the first place.
That overview, I'm using the word overview because that's what it would be called in kind of Logic or Cubase or anything like that, but that overview that they're writing, if you've got a really, really smooth curve and then you squash it up and you physically haven't got enough pixels on your screen to represent that curve, then you're, by doing the zooming of the wave, you're basically throwing away information yourself and reducing the quality of it. And then when I re-stretch it, I'm having to fill that in. So we're going to lose high frequency data there. Also, by squashing it that way, we're going to lose bit depth on it. So there's so much that's lost from that. But the fascinating thing for me was the fact that what we recovered was still perfectly audible. Actually,
they've done a pretty good job of it.
Yeah. I mean, it has to be good enough to use, and I think, like anything, when you're designing a piece of software, you want to write something that's going to give you enough of the wave that it's going to be good enough to the user, but not so much of the wave that it's going to eat up processing power when you're trying to redraw and you want to quickly zoom in and out of stuff. So obviously what you're seeing there with that, what you're discussing there, is the natural trade-off between those two things. So clearly what they're giving you is good enough for you to do your work and good enough for us to actually recreate what you said from it, you know, which is good.
How's that old camera that I told you getting on?
It's wonderful, and it's so lovely that your old Canon C100 is going to make its way back onto Computerphile. But I am still getting adjusted with looking at the camera, and I've got you down here on WhatsApp.
Most people who watch Computerphile are used to people not looking at the camera anyway.
Yeah, no, that's fair enough.